Recording is thinking of starting. Caitlin, that's not an appropriate picture you have. All right. Recording is started. All right, everyone, welcome. This is the test review for Unit 5. This is our last unit before the final. And don't forget, I'm going to say this again at the very end. Remember, the NWEA test is Tuesday next week. Make sure that you are awake and logged into the Class Connect because I have to proctor you. I have to approve your test when you log in. So everyone, juniors, seniors, sophomores, freshmen, everybody needs to log in on Tuesday so I can proctor your test to take NWEA. Do your very best. If you show improvement, you will be exempt from taking your final in pre-calc. So that means that this Unit 5 could be your last test. Exciting, I know. I emailed everyone some information on how to study for your math test. So maybe in your best interest to kind of go through some of that. It goes really quick. It's through the Khan Academy and it's tailored to whatever score you entered. So study up, do your best. The NWEA is about 50 to 53 questions max, I think. Yeah, so if you get exempted from the final, you are more than welcome to still participate in the review session. And even if you want to still take the final just to see if you can do better, you can. All right, all right. All right, let's get the show on the road. All right, number one. So we have to convert points, rectangular to polar. When r is greater than 0 and your angle is between 0 and 2 pi. All right, so we want to convert this point here. Now, I give you the conversion. It's nice of me, so you don't have to hunt down for it. But rectangular to polar is just this formula. So everyone quickly convert this point into polar. Ready, go. My phone. I'll give everyone, say, a minute and a half.
I'm assuming you want this exact since you didn't tell us what you're round to.
I do want exact. Yep. All right. In chat, see if you can tell me what the final answer is. Yeah, make sure you are in radians. It matters. can even use your unit circle on this one, I believe. Yeah, so you are correct. If you got 4 for so remember polar, so when you're saying the x value is 4, well, it's not. Remember, it's r comma theta. That's polar format. So your r value is 4. So I agree with you on that. So there's the setup. You can reduce that fraction for your arctan, and then you can look at your unit circle. So it looks like Caitlin got 4 pi over 3. Antonio got negative pi over 3 because he used his calculator. So I got 2 pi over 3. Look at my unit circle to make sure I agree with my answer I typed. 2 pi over 3. Pi over x. Yeah, I agree with my own answer. 2 pi over 3. Yep. Yeah, Caitlin is right. It's either one or the other. So it shows for your test, just do the first occurrence that appears on your unit circle going counterclockwise, which would be 2 pi over 3. That's a good point, Caitlin. Good point. But it's not the fact that it's the first occurrence. Let me kind of backtrack on what I just said. You have to look at what quadrant you're in now. So your rectangular is -2, 2 rad 3. So that is in quadrant 2. X is negative, Y is positive. So our answer should be something that appears in quadrant 2. And 2 pi over 3 does. Does that make sense, Caitlin? Yep. Yeah, use your unit circles. Identify what quadrant we're supposed to be in, and that really narrows down where you should be looking. And then you should have your unit circle in front of you. You should know what your arctangent values give you. All right, good. All right, next problem. All right, complex numbers. So we want to suppose D and E are complex numbers where the absolute value of D, what's the other name for this? Absolute value, what is this also called when talking about complex numbers? What is that vocab word? Crickets. Crickets. What's that word called? It's from 505 day 2. Give up. Everyone gives up. Modulus. There you go, the modulus. It is the modulus. Yeah, so absolute value of a complex number, same thing as calling it the modulus. There, it's the same thing. The modulus. Okay. All right, so the modulus of d is equal to 3 rad 5, and the modulus of d plus 5 is equal to 7 rad 2. On what interval must modulus of f fall on? Well, you're going to use this formula. And all you're going to do is just plug the stuff that you know that's given to you into it, and then I guess from there, we just solve. So subtract 3 rad 5 both sides. 7 rad 2 minus 3 rad 5. What does that equal? Oh, did I mistype? Oh, yeah, I did mean D and F. I did mean D and F, not D and E. Whoops. Typo. So that should be an F. Change my pen color to white. Yep. D and F. Thank you. All right. So again, 7 rad 2 minus 3 rad 5. Can we combine those two terms? We sure can't, so that is the answer. Yeah. Yeah, 7 rad 2 minus 3 rad 5, because the radicands are not the same, the 2 and the 5, you cannot combine those. That's like saying 7x minus 3y. They are incompatible terms, so they stay separate. And that's your answer. On interval notation, it's from 7 rad 2 minus 3 rad 5 to infinity, because the modulus of f must be greater than or equal to. So from that value, it increases forever. So that is the interval notation right there. Good. All right, next problem says convert equations. We must convert to rectangular form. So you're giving r equals this fraction here. And on the far right, I give you, I think this should be all you need in order to convert this equation into rectangular form. Now from here, let's see. We need to do some stuff to this problem. Ideas, what should we do? Isn't negative 2 cosine theta? Ideas, what should we do? Get rid of the fraction. Yeah. And how do I do that, Antonio?
Multiply both sides by 3 sine theta minus 2 cosine theta.
I agree. I agree with Antonio. Multiply both sides by that denominator, and that will cancel it out on the right-hand side, and then we're going to have r times, well, the entire piece. And then we need to distribute that r to both terms. So that's how I have 3r sine theta minus 2r cosine theta equals 15. Now, can I use any of these to convert? Put in x and y. Yep. So I now have r cosine theta and r sine theta. See, there's r sine theta, there's r cosine theta. So I can replace those with the x and y values. So r sine becomes y, and then r cosine becomes x. And then from here, we can solve for y. So add 2x to both sides, then divide everything by 3. And that's how we get y equals 2/3 x plus 5. Good. All right, magnitude and direction of a vector. So we want to go from this vector to component form. So right now, this is in magnitude and direction format. We want this into component form, which is basically an x and a y value. We want to round to the nearest hundredths. Does anybody recall the conversion we use? This is pretty recent. This is 5.09. I guess actually not that recent. It was, I think this was on April 6th. Or no. Hold on. 6, 7, maybe the 8th. Maybe April 8th. I don't know. I'm guessing.
I think I found it. Don't we have to put the first value here set with cosine 60? No. Cosine of this. And then you're going to do same thing with sine.
You are correct. If you take the r value times cosine of theta, comma, r value sine of theta. And make sure that you are now in degree mode. This is in degrees. So this test, you have to go back and forth between radians and degrees depending on the problem. Be very, very careful. All right, what's the answer, everyone? What is the answer? Remember, we want to round to the nearest hundredths. So that's 2 places. Yeah, sorry, she heard the wind. All right, what's the answer, everyone? All right, negative 4.33, comma 2.5. People that say that. I agree. All right, everyone's good on this one? All right, number 6. All right, addition, subtraction, and scalar multiplication of vectors. So we have vector D and vector G are those coordinates. We want to represent vector D minus vector G using the head to tail method. So If you're all caught up on 5.09 quiz, you did this. Except I don't think yours was minus. I think yours was just like a straight vector plus vector. So this is a little different. We went over this in class that when you have a minus, you have to distribute this minus, in this case, to this vector g, like I have here, and then rewrite it. So negative vector g is 2 comma negative 5. You have to do this on your test. On your quiz, you didn't have one like this. Now, for the head to tail method, you have to plot both vectors. So I'm just, on this first graph, I'm just showing plotting vector d and negative vector g. Now for the head to tail method, all you're going to do is pick up this negative vector g, pick it up and stick it at the end of vector d. And that's what I did over here. So once you do that, wherever this points to, that is where you draw your final vector. And then that is the answer. And then you would write your answer in the box or wherever it tells you to do. Good.
Question.
Yeah.
So to clarify, you put this over here, basically. Just moved it up.
That is the head to tail method, yes.
Okay.
Yep. Also, your quiz, instead of using initial and terminal point, they used head and tail, and I didn't emphasize head and tail, and I don't think your modules did either. But when it talks about the head and the tail of a vector, the very front, the arrow, this is the head of the vector, and the starting point is the tail, it's the back end. So there's the tail, there's the head. Just want to clarify that because I didn't before. All right, now this method, same question, but instead of being the head to tail method, so let me go back to that previous page to see the word difference. We had head to tail method on this slide, and then on this next slide, same problem, but it says parallelogram method, so different. Going to be the same answer, it's just going to be different on how it's represented on the actual graph. So same thing, you want to do negative g, and I'm showing that on this first one. And then for your parallelogram, all you got to do is you stick this one at the end of this one, like we did on the previous page, but you also want to stick this vector at the end of this vector. You'll see that when I uncover it. And now in this method, you now have two arrows, two vectors pointing to the answer instead of just one. So this would be the parallelogram method. And remember, it does matter where you draw your vectors. So when you are drawing these two vectors, you have to start here and then drag it, or however you graph it in the module, to this. That way the arrow is pointing in the right direction. If your arrow is the wrong direction, well, it's going to mark it wrong because it is wrong.
You basically want these three to meet here, correct? This
Sure
one
do.
going that way, this one going that way, this one going that way.
Mm-hmm. Right, Sarah? All right, next problem. It looks like Neuro cut off what it's supposed to say. All right, so we want to know, how do you plot the polar coordinate 3, negative? 5 pi over 6. So on your test, it's going to be kind of basically fill in the blank. You're going to have a bank of choices. So quadrant 1 to 4, and then these two is the same as quadrant as and is the opposite quadrant of. All right, the first one, using the angle of rotation, we will be in blank, and this should say if R is positive. Let me add those words in because it cut it off. If R is positive. And blank if R is negative. And don't forget, this is your R value, and then this is your theta. So this problem, you be very careful. So when using this angle of rotation, so using this angle of rotation, so it's negative 5 pi over 6. So we are going to rotate clockwise a total of 5 pi over 6, which is
150 degrees.
Which is rotating clockwise 150 degrees. So that means it puts us at what radian value? Everyone should have the unit circle.
7 pi over 6.
You are correct, Antonio. 7 pi over 6. All right. So that's where we are right now. So using the angle rotation, we will be in blank if R is positive. So what's that first blank, you think? Quadrant 3, yes. Quadrant 3. So again, using this rotation, we rotate. We are now at 7 pi over whatever Antonio said. So that's quadrant 3. And we are going to stay there if your R value is positive. So we're going to stay in quadrant 3 if your R value is positive. Now, if the R value is negative, where are we going to be? Dun, 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 dun. Think about it. Think about it. What does having a negative R value do? So let's say that we're in quadrant 3 right now. R value is positive, so we would stay there at a radius of 3. But what if it was negative? What does a negative R value make us do? Thank you, Caitlin. Yes, it makes you rotate 180 degrees. Or like Antonio says, you just follow the line to the diagonal quadrant. It's the same idea, right? Yeah, rotating 180 or following the line to the opposite, the diagonal quadrant is the same thing. So that means we would be in quadrant 1, like some of you have said. All right, part 2 says because r is positive, we actually already answered this. Because the r value is positive, the point will be blank the angle of rotation. So I'm going to give you a hint for this second part. It's using one of these two choices. So because r is positive, are we going to be in the same quadrant as the angle of rotation, or are we going to be in the opposite quadrant of rotation? In the same, yeah. Yep, we're going to be in the same quadrant. So hopefully you understand this, because the way that it's kind of presenting this question is can be confusing. If we didn't go over this problem, I could see people misinterpreting what it's trying to ask you. So you may want to watch this recording again to kind of just fully understand what this problem is going over. But let's keep going. We're running out of time. All right, next one. We want to simplify this. And I was kind enough to give you this little conversion dealy of when the I exponent is going to be, well, the remainder is going to be 0, 1, 2, or 3. Remember, so once we simplify this, you want to take the exponent of the I, divide by 4. And if the remainder is 0 to 3, that is the answer for that piece. So let's do this. Actually, I'll give you all, how about this? I'll give all of you 35 seconds to solve this. No, that's not long enough. I'll do a minute. 1 minute. Oops, wrong button. One minute to solve this problem. Yeah, make sure you subscribe. I'm only like 990 subscribers away from a bronze plaque. At this rate, I might get one in 15 or 20 years. All right, what is the answer, everyone? We got I, another I, more I's. We got lots of I's. Let's see if the I's have it. It is I, yep. Yep, so here's the math. Pow, multiply now, right? And then same basis, you add exponents. And then we take that 69 and we divide by 4. I think it's 17 remainder 1. And then we go over to the right here, and remainder 1 means that it equals I. So, yep. Pretty neat. Pretty neat. You probably didn't add your exponents, did you? You probably multiplied them.
Well, technically, didn't you? Well, this is what I did. Okay, so I can't get my pointer to work. Right here, I was trying to add these first instead of multiplying them first. So I was doing it backwards.
Yeah, that's bad. Can't do that. All right, next problem. So what are the fifth roots of 2 rad 3 minus 2i? So this is a complex number. And, oops, I thought I covered some of this stuff up. Oh, well. Well, I gave away part of the answer already. So we have to first convert this complex number into polar format. And that work to convert this into polar is here. And I don't have the conversion on this page because we did one like this pages ago, right? So refer back to that one. So we get r is 4, and then your angle is 11 pi over 6. All right. And I also want to point out for this problem, make sure that when you get your angle, which we got negative pi over 6, it needs to be positive. So we have to do a rotation, a full rotation, 2 pi to get the coterminal angle. And hopefully it's positive. It's not, do it again. You keep doing it until it's positive. And that's why I added 2 pi here. And doing that makes it 11 pi over 6. So this piece is really important. Make sure your found angle is a positive value and not negative. All right. Let's see. Also, something to point out, looking at this on the Argand plane, this 2 rad 3 minus 2i, if you can visualize it, you are in quadrant number 4. So knowing that we are in quadrant 4 for this point, this angle should also appear in quadrant 4. So it's a kind of a nice way to quickly check to see if we're in the right location. If we're not, we mess something up. So quadrant 4, angles at quadrant 4, we're good. All right, and then the setup. So these are just, all of these are the same. I don't have the formula on this page, so you might want to refer to 507 day 2 for the actual de Moivre theorem of the setup of plugging it in. But basically for the first, so you're doing the 5th root, so you should have 5 answers. So z sub 0, z sub 1, z sub 2, z sub 3, z sub 4. Whoops, z sub 4. Uncover the wrong box. Oh, my coloring didn't stay. So you're just increasing this value because it goes from 0 to n minus 1. If you recall from this 507, this was like 2 weeks ago we did this on April 6th, I believe. So 0, 1, 2, 3, 4, and that's it. And then we just plug and chug. Just do the math. And that's how you get all of these answers. That's it. So again, convert into polar format, use the de Moivre theorem, and plug the stuff in, and then chug, and you're done. Ooh, I got 15 subscribers now. Nice. All right, next problem. We want to, it says, what is the vector and component form? All right, so you're given this graph, you're given a vector. We need to put this vector in component form. So all you got to, well, there's a formula, right? Here's the formula in the top right-hand corner. So you just get the tail and the head coordinates, and you just plug it in. But another way to do it, if you're super creative, I am going to, on my screen, I'm going to just draw over this vector. All right. And then once you do that, all you're doing is picking it up and moving it to the origin. Look at that. So you just basically pick it up, move it to the origin, and then wherever it points, well, that's the answer. So this is going to be what, -4, -3, it looks like. Hey, that's the answer. That's all it is. That's a super easy problem. At least it should be. You can also think of this as, let me use different, I'll use same color. No, I'll use blue. So you're going left one. Oops. Oh wait, that's not the pen tool. You're going left one and up one. So you're going to go left one and up one. It's the same idea. You're just doing a translation. Left one, up one to get to the origin with the tail. All right, next problem here. All right, more addition of vectors. We have f and g, and it wants to know what f plus g is in component form. So here's my question to you. Are these two vectors in component form? Antonio says yes. Somebody else? Are they in component form? Yes, they are. They are already in component form, which means all you gotta do is just add the corresponding values. You do -4 plus 6 and 8 plus 11. Well, that was a boring problem. Should be a freebie. All right, convert equations. We want to convert this one into polar form. All right. What do we got to do to convert to polar? Now, this is 5.04 was like, it's probably like a month ago. We started Unit 5 on March 25th. So it was about a month ago we did this. It is a circle. Yep. How do we convert? How do we convert? What should we do? We know it's a circle, but we have to convert it into polar form. So what do we do? Ideas?
Look frantically in our notes till we find the answer.
You can't square root both sides. Nope. Oh, good guess, but nope. Nope. Can't state the radius. Nope. And Chloe, the reason why is because you have a vertical and a horizontal shift, so it's not as easy just stating a radius. If it was at the origin, then yes. Good guess, though. Jacob says foil. Jacob is correct. You want to foil it. So x minus 3 squared, you're going to write that twice, and you're going to foil it. When you foil the x minus 3 binomial, you should get these four terms, x squared minus 3x plus 9. Is that clear how I got those? All right, and we do the same for the y binomial, the y plus 1 times y plus 1. You foil that out, you will get this. And then we combine like terms. And you also want to reorder your terms. You want your x squared and y squared first, followed by your x's and y's, and then your constants. So I kind of skipped some steps here. I went ahead in my head, I said, and I don't recommend this, I actually should have showed more steps because I would expect all of you to do the same. 9 plus 1 is 10, and then I subtracted 10 from both sides, and that's how I get 0 on the right-hand side and no constants on the left side. I really should have shown at least one more step of how I did that, and I didn't. All right. Now from here, you need to look. See, I didn't include the conversion stuff. You're going to have to go back to 504 lesson and look at the how to, I guess, the conversion, because I didn't include it on this PowerPoint. I can't make everything too easy for you. But x squared plus y squared. Do you recall what this equals to? What is x squared plus y squared equal to? R squared. I think that sounds right. It is. Yep. X squared plus y squared becomes r squared in the conversion. And then what does x become? Yeah, these conversions are actually on one of the previous slides in this lesson or this review. Yep, r cosine. Yep, and then y becomes r sine. So again, x becomes r cosine theta, y becomes y sine theta. Then we are going to move these two terms to the other side. So that way r squared is by itself. And there's a reason why we're going to do this. So we're going to add 6r cosine theta to both sides, and we're going to subtract 2r sine theta both sides. And then our final step, you want to guess what our final step is? Yep, Caitlin's right. Divide everything by r. Yep, if you have to go, feel free to go, and you can watch the rest of this review later. Because there's quite a bit more to go over. So I am definitely going to go over time, but if you have other classes, you need to go to those classes. Chloe, I will send it to you through Skype. Okay. The questions seem like they go on forever. All right. I think we're getting pretty close, though. All right, multiplying and dividing complex numbers in polar form. All right, so we have 6 CIS, this stuff, divided by rad 3 CIS, that stuff. So division, I'm first going to write it as, well, top and bottom. I'm not really sure why I expanded the CIS, because you don't have to. I did. I don't know why. There's really no reason for me to do that. So I wrote the CIS in expanded form. You can leave it in the short form. It doesn't change anything. But when you divide two complex numbers, all you're going to do is divide your R values and subtract your thetas. That's all you got to do. 6 divided by rad 3, and then I went from the expanded form back to short form. I don't know. I don't know why I did that. There is no reason for me to even go to expanded. All right, 7 pi over 4 minus 7 pi over 6 gives us 7 pi over 12. And 6 divided by rad 3, after you rationalize it and simplify, I didn't show the work. All of you are more capable of doing that. You get 2 rad 3. I think there's 15 questions on the test. All right, next one. See how close we are to being done. We got this and one more. All right. parametric equations, where t is on the interval -2 to 6. So this question wants you to identify your initial point and your terminal point. How do I do this? How do I find the initial point? How do I find the initial point? How do I find the initial points? No one knows. Think of something simple. It's not complicated. It's a really simple way to do it. I want the coordinate of your initial point. Yikes.
Don't we sub the intervals in?
You do. That's all you do. That's all you do, actually. You're replacing your first, remember, and this is your t interval. So you're plugging in -2 into t here and here to get your x and y coordinates for your initial point. So here is the x coordinate, and then here is the y coordinate setup. And yeah, you just plug it in and plug and chug, right? We get rad 5 comma 4, so that's your initial point. And then for your terminal point, well, you just go to the end of the interval, which is at 6. You do the same thing. You're plugging in 6 into both equations to get both x and y. You get that. Oops, I didn't. So obviously I copied my first one and I did not change the values. Whoops. Yeah, it's that. I just didn't type it in. Something I would do. All right, last problem that you'll see in your test. We want the initial point of vector A. Sorry, the initial point of vector A is 8, -1. And the terminal point is 3, -5. What is the value of this? What does this symbol mean? Modulus was the absolute value bars. This is not modulus. What do the double absolute value bars mean? Nope. So modulus referred to complex numbers. This is talking about a vector. Magnitude, length, magnitude, same difference. Yeah, it's magnitude. Yep. This is the magnitude, which is really the same equation as it was for when we did modulus for complex numbers. So you first need to convert to component form using that equation. And make sure you plug it in right. So initial point and terminal point, make sure you plug in x sub 1, x sub 2 correctly. So remember your x sub 1 and y sub 1, that's your initial point. X sub 2, y sub 2 is your terminal point. So that's your first step, is converting it into component form. All right, so now we're component form. And then from here, it's super easy. It's just same as the modulus equation. It's the square root of your x value squared plus the square root of, the square of your y value. And you type all that stuff in, hit enter, and we get rad 41. Okay. So rather than have the TGA, the actual problem, I put where to find an example of it. So for TGA 1, look at the bell work from 5.11 day 1. For TGA number 2, look at the bell work from 511 day 2. So that one's day 1, that one's day 2. And then the TGA number 3, you want to look at the entire lesson of yesterday's lesson, 511 day 3. Make sure you do that. I will actually show you the questions. Hold on, let me. Pretty sure I have it pulled up in a Word document. I do. All right. Everyone can see that, right, Antonio? You're still here?
Yeah, but it's blue, but it's fine.
I made it blue. All right. So your first one, you're going to have to basically, you're given this equation here. You're going to have to fill in this table of all of these points. And then once you fill it in, just like on the bell work, you're going to have to graph it on the polar graph by hand. Do not use Desmos or GeoGebra. If you turn in a digital graph, I'm not giving credit for it. I want to see you plot the points, and I want to see all the points plotted. And then you obviously connect these points to do a graph. You can sure use Desmos or GeoGebra to check your answer, sure, but I want to see your hand graph. So when you do your hand graph, you can, if you got a touch screen, do it. If you don't have a touch screen, take a picture of your work and throw it into a Word document and convert it to PDF, of course. All right, number 2, super easy problem. You want to do the transform this vector by this matrix. Make sure you show your work. Super straightforward, easy problem. Number 3, Antonio, you want to read this for us?
Yes, a quick to answer this question real quick. Number 2's TGA, the bell work is day 1 of 511. Antonio had a dream that he was a legendary baseball player. In this dream, he hit a baseball with an initial velocity of 132 feet per second at an angle 30 degrees with the horizontal. The baseball hit the bat when the ball was 3 feet above the ground. When Antonio woke up, he Googled what the average MLB average initial velocity of a hit baseball was, also called the exit velocity. He learned the average exit velocity was, is that 69 or 89? Or 89?
I think it's 89.
89 miles per hour, or about 61. Where's 81 again? 61.
61
per second.
Yep.
No one interferes with the baseball. How long does it take till the ball hit the ground? Round your answer to nearest hundredth of a second. Show your work. No work equals no credit. How far does baseball travel horizontally? Use your rounded answer from part A in your calculations. Round your answer to the nearest hundredth of a foot. Show where your answer. No work is no credits.
Yeah. So really, you guys watched the lesson from yesterday. It's very similar to those examples. One thing that I put in your part B, I say use your rounded answer from part A in your calculations for part B. So in yesterday's lesson, I use the exact values when doing like the second half of the problem. I'm telling you, don't do that. I want you to use your rounded answer that you found in your part A to answer part B. It'll make everything easier, at least for part B for sure. And then, make sure you round correctly. I think here I said round your answer to the nearest hundredths. Same thing for part B, nearest hundredths. So just like yesterday's, it's not any more tricky, confusing. In fact, it might be a little easier than yesterday. So that's the TGA. Right. All right, and the password. Oh, so the test is scheduled for Monday and Wednesday next week. But some people asked me if I could change the date to have it available today, and so I'm going to do that. So when I show you the password, you'll be able to access the test today and this weekend, and that way you can get it out of the way. You can do your test, and then you're done with it. And then next week, don't forget your NWEA English is on Monday. The math test is on Tuesday. Everyone needs to log in. You'll see in your Class Connect, you want to log in the morning and take the test. Again, if you show improvement, you are exempt from the test. What else? Yeah, don't forget. Don't sleep in. Don't miss. Everyone must take this test.
Dr. J, for the TGA number 2, what lesson can we go back to look at again?
Yeah. 511 day 2 bell work is an example of it.
Okay, thank you.
Mm-hmm. All right. So, any questions before I show the password?
We would not be reviewing for the NWA, correct?
We are not reviewing for the NWEA. Okay. I sent everyone an email about it.
Is it following? Well, I don't know if you put it in there or not. Is it have part stuff from last semester or only this semester?
For your final?
NWA finals have everything on it, but the NWA specifically.
I don't know. It's the same thing that you took every single time. I don't know. I haven't seen the test. I'm not allowed.
Oh, okay.
Just kind of funny. All right. All right. There you go. Password is last unit. Sad face. Exclamation point. All right. All right, everyone. Good luck. I will see all of you Tuesday next week for the NWEA. Good luck.